In these problems, we're looking at some algebra that requires more than one step. Let's look at the first one. It says, if x minus 3 equals 4, what is the value of x minus 7? So what you'll do here is you'll solve this first, get a value for x, and then plug it into this expression. So let's do that. To solve for x, I want to get x alone here, so I'm going to get rid of this minus 3. By doing the opposite, I'll add 3 to both sides, and I get x equals 7. Now I can take that 7 and plug it in here. Instead of the x, I'll put in a 7, write the rest of the expression, 7 minus 7, well, that equals 0. So the answer for this one is 0. Now that's a fairly simple example. A lot of these get much more complex. Let's take a look at the next one. This one says x plus 1/3 equals 3/8. What is x minus 4/9? So again, we're simply going to solve for x, or maybe not so simply solve for x, and then plug in x over here and try to get a value. Because we're dealing with fractions, this gets a little more complicated. And the first thing I think I'll do to deal with these fractions is to get the denominators the same. I'm going to decide to multiply this fraction, 1/3, by 8 over 8. And I'm going to multiply this fraction by 3 over 3. What that'll do is I'll have 3 times 8 on both the bottoms, so I'll get 24ths. So up here I've got 1 times 8, that's 8. On the bottom, 3 times 8, that's 24. And over here, 3 times 3 on the top, and 8 times 3 on the bottom is 24ths. And I'll just fill back in the rest of the equation. So all I did was decide what factor of, what different arrangement of 1 I would multiply each of these fractions by so that I could get the denominators the same. Multiplying 1/3 by 8 over 8 is multiplying 1/3 by 1. So it doesn't really change anything. I don't have to do it to both sides. I can multiply anything by 1 and keep everything the same. And in fact, 8/24 is 1/3. 9/24 is 3/8. Now I'm ready to solve this. Again, all I'd have to do here is get rid of this extra term, 8/24. I would subtract 8/24 from both sides, and you would get x equals 1/24. So that's the value that I can then go on and plug into here. And I would get 1/24 minus 4/9 equals what? And here we are again trying to do addition or subtraction with fractions, and the denominators aren't the same. You could multiply this fraction by 24 over 24 and this fraction by 9 over 9. That would work. It would lead you to a point where you have to do some reducing later. I noticed that both of these denominators have a factor of 3 in them. So if I pull that out, this would be thirds. So I'm going to multiply this side by 3 over 3. And I'm going to multiply this side. If I pulled a 3 out of 24, it would be eighths. Multiply by 8 over 8. And this should give me common denominators. Let's see, 3 times 1 is 3. And 3 times 24 is 72. 4 times 8 is 32. And 9 times 8 is 72. Yep, that did indeed work. If that didn't make sense, the way I got the thing to multiply to get common denominators, you could just multiply by 24 over 24 or 9 over 9. That would work too. Now I'm going to do my math here. 3 70-seconds minus 32 70-seconds is, well, negative 29 70-seconds. And that is our answer. A little complicated because of the fractions. Let's look at one more, even more complicated example. This one says, evaluate x cubed minus xy minus the absolute value of x plus 3y minus the quantity in negative y cubed. If 4x minus 8 equals 2x and y equals negative the square root of 9. That looks just very complicated. So we want to take this step by step. We want to solve these to find a value for x and a value for y, plug them in, and then do the arithmetic. I'm going to start over here with y because this is pretty simple. The square root of 9 is 3. So the negative square root of 9 is negative 3. So y equals negative 3. Here we have 4x minus 8 equals 2x, a pretty typical algebraic equation. I've got x's on both sides, so I'll start by subtracting 2x from both sides. And I get 2x minus 8 equals 0. And then I will remove this term from this side by doing the opposite. I'll add 8, but I've got to do it to both sides. And I get 2x equals 8. When I divide by 2, I get x equals 4. So now we have our values for x and y. We can simply plug them in, or maybe not so simply, plug them in here and try to figure it out. So let's start. We've got x cubed. Well, x is 4, so that's 4 cubed minus, and for any kind of multiplication, I'm going to use parentheses here so we don't get mixed up with our signs. X times y. Well, x is 4, y is negative 3. Then I have a minus sign, and then we have this absolute value. So the absolute value of x, which is 4, plus 3 times y, which is negative 3. Now I've run out of space here. And then finally, minus quantity, negative, and then I'll put my y in here, negative 3 cubed. So that's the whole thing. Had to run over a little bit. Let's go through and figure out what we can here, just a step at a time. 4 cubed, that's pretty easy. It's 4 times 4 times 4. That's just 64. So I'll write that down. And then we've got a minus 4 times a negative 3. Well, 4 times a negative 3 would be a negative 12. And a minus a negative 12 would be a plus 12. So I'll put that down. Now let's figure out what's in the absolute value here. We have 3 times a negative 3. That would be a negative 9. 4 plus a negative 9, or 4 minus 9, would be negative 5. But then we take the absolute value of that, and we get a positive 5. And then we put this minus sign in front of it. It comes out as minus 5. And then we have this whole chunk here, minus a negative 3 cubed. Well, what's negative 3 cubed? Well, 3 cubed is 27. When you cube a negative number, you keep the negative sign. Odd exponents, the negative sign stays. Even exponents, it becomes positive. So that's a negative 27 in there, but we have a minus and a minus. I think I forgot a parentheses there. Now, I like to think when I have minuses arrayed right next to each other, separated only by parentheses, of every 2 minus signs becoming positive and kind of disappearing. So those 2 would become positive, at least with just 1 negative sign. So this is going to evaluate to a negative 27. So I'm going to just put that in here. So this is what the whole thing came out to. We just have a little bit of arithmetic to do yet. So let's see, 64 plus 12 would be 76, and negative 5 and negative, so minus 32, and that's going to be 44. So our answer here came out to be 44. A lot of places to make mistakes here with dropping a sign or doing some incorrect arithmetic, so it probably pays to double check your answers on these.